CodePlan, repository-level coding using LLMs and planning. Software engineering activities such as package migration, fixing errors reports from static analysis or testing, and adding type annotations or other specifications to a codebase involve pervasively editing the entire repository of code. We formulate these activities as repository-level coding tasks. Recent tools like GitHub Copilot, which are powered by large language models, LLMs, have succeeded in offering high-quality solutions to localized coding problems. Repository-level coding tasks are more involved and cannot be solved directly using LLMs, since code within a repository is interdependent, and the entire repository may be too large to fit into the prompt. We frame repository-level coding as a planning problem and present a task-agnostic framework called CodePlan to solve it. CodePlan synthesizes a multi-step chain of edits, plan, where each step results in a call to an LLM on a code location with context derived from the entire repository, previous code changes, and task-specific instructions. CodePlan is based on a novel combination of an incremental dependency analysis, a change may impact analysis, and an adaptive planning algorithm. We evaluate the effectiveness of CodePlan on 2 repository-level tasks: package migration, C#, and temporal code edits, Python. Each task is evaluated on multiple code repositories, each of which requires interdependent changes to many files, between 97 files. Coding tasks of this level of complexity have not been automated using LLMs before. Our results show that CodePlan has better match with the ground truth compared to baselines. CodePlan is able to get 5-6 repositories to pass the validity checks, for example, to build without errors and make correct code edits, whereas the baselines, without planning but with the same type of contextual information as CodePlan, cannot get any of the repositories to pass them. MosaicFusion diffusion models as data augmenters for large vocabulary. Instance segmentation. We present MosaicFusion, a simple yet effective diffusion-based data augmentation approach for large vocabulary instance segmentation. Our method is training-free and does not rely on any label supervision. 2 key designs enable us to employ an off-the-shelf text-to-image diffusion model as a useful dataset generator for object instances and mask annotations. First, we divide an image canvas into several regions and perform a single round of diffusion process to generate multiple instances simultaneously, conditioning on different text prompts. Second, we obtain corresponding instance masks by aggregating cross-attention maps associated with object prompts across layers and diffusion time steps, followed by simple thresholding and edge-aware refinement processing. Without bells and whistles, our MosaicFusion can produce a significant amount of synthetic labeled data for both rare and novel categories. Experimental results on the challenging LVIS long-tailed and open vocabulary benchmarks demonstrate that MosaicFusion can significantly improve the performance of existing instance segmentation models, especially for rare and novel categories. Code will be released at the project's website. Dynamic ASR pathways, an adaptive masking approach towards efficient pruning of a multilingual ASR model. Neural network pruning offers an effective method for compressing a multilingual automatic speech recognition (ASR) model with minimal performance loss. However, it entails several rounds of pruning and retraining needed to be run for each language. In this work, we propose the use of an adaptive masking approach in 2 scenarios for pruning a multilingual ASR model efficiently, each resulting in sparse monolingual models or a sparse multilingual model, named as dynamic ASR pathways. Our approach dynamically adapts the subnetwork, avoiding premature decisions about a fixed subnetwork structure. We show that our approach outperforms existing pruning methods when targeting sparse monolingual models. Further, we illustrate that dynamic ASR pathways jointly discovers and trains better subnetworks, pathways, of a single multilingual model by adapting from different subnetwork initializations, thereby reducing the need for language-specific pruning. DualToken-ViT, position-aware efficient vision transformer with dual token fusion. Self-attention-based vision transformers, VITs, have emerged as a highly competitive architecture in computer vision. Unlike convolutional neural networks, CNNs, VITs are capable of global information sharing. With the development of various structures of VITs are increasingly advantageous for many vision tasks. However, the quadratic complexity of self-attention renders VITs computationally intensive, and their lack of inductive biases of locality and translation equivariance demands larger model sizes compared to CNNs to effectively learn visual features. In this paper, we propose a lightweight and efficient vision transformer model called DualToken-ViT that leverages the advantages of CNNs and VITs. DualToken-ViT effectively fuses the token with local information obtained by convolution-based structure and the token with global information obtained by self-attention-based structure to achieve an efficient attention structure. In addition, we use position-aware global tokens throughout all stages to enrich the global information, which further strengthens the effect of DualToken-ViT. Position-aware global tokens also contain the position information of the image, which makes our model better for vision tasks. We conducted extensive experiments on image classification, object detection, and semantic segmentation tasks to demonstrate the effectiveness of DualToken-ViT. On the ImageNet 1K dataset, our models of different scales achieve accuracies of 75.4% and 79.4% with only 0, 5G and 10G flops respectively, and our model with 0G flops outperforms LightViT using global tokens by 0.7%. Robotic offline RL from Internet videos via value function pre-training. Pre-training on Internet data has proven to be a key ingredient for broad generalization in many modern machine learning systems. What would it take to enable such capabilities in robotic reinforcement learning, RL? Offline RL methods, which learn from datasets of robot experience, offer one way to leverage prior data into the robotic learning pipeline. However, these methods have a type mismatch with video data, such as Ego4D, the largest prior datasets available for robotics, since video offers observation-only experience without the action or reward annotations needed for RL methods. In this paper, we develop a system for leveraging large-scale human video datasets in robotic offline RL based entirely on learning value functions via temporal difference learning. We show that value learning on video datasets learns representations that are more conducive to downstream robotic offline RL than other approaches for learning from video data. Our system, called VPTR, combines the benefits of pre-training on video data with robotic offline RL approaches that train on diverse robot data, resulting in value functions and policies for manipulation tasks that perform better, act robustly, and generalize broadly. On several manipulation tasks on a real WidowX robot, our framework produces policies that greatly improve over prior methods. Our video and additional details can be found at the project's website.